Okay, hey, welcome back. This is 0965 7.4. Um, Believe it or not, I've done this video like 3 times and I keep forgetting to record my voice. So I'm just going to talk over the video that I recorded. Okay, so we're beginning by recalling what we did in arithmetic. So we're adding fractions with unlike denominators. There's a lot of different ways you could probably approach this, but the way we're going to approach it in this class is by kind of factoring the denominator and then making the two denominators look exactly the same by multiplying in constants in the top and bottom. Okay, so on the left you can multiply in what's missing, right? It's missing a 3. So I'm going to multiply top and bottom in this first fraction here by 3, and then the second fraction is kind of missing a 2. Okay, so I'm multiplying top and bottom by 3. The other guy is missing a factor of 2, so I'm going to multiply top and bottom by 2. Okay, there we go. Then I'm going to rewrite the stuff. So 3 times 3 is 9. 5 times 2 times 3 is 30. And then plus 4 all over 30. And then add the two numerators together, you get 13 all over 30. And then we're kind of stuck. We can't do anything here because 13 and 30 don't have any common factors, so you can't reduce it. Okay. Okay, great. That's the idea. We need to now extend this to variables, and that's kind of our next topic. Okay. Okay. Before we actually put it all together, though, we're just going to work with finding that LCD thing, this least common denominator. You can actually literally in the previous problem you could have multiplied 10 times 15 and use that as your denominator, but we want the least common denominator. Okay. And here what I'm doing is kind of setting up the visual learner approach to this problem. So you could kind of imagine each denominator is like a picture, and in each picture, after you factor it, you'll see all these common elements. So the first picture, let's pretend it has 2 trees and a house, and then maybe a cloud. The second picture has a house and 1 tree and 2 clouds. There's 1 cloud, there's 2 clouds, and a sun. Let's put a sun in there for fun. Okay, so the process of finding this common denominator is basically you're making these 2 pictures kind of the same by adding in as little as possible, right? So to kind of make it work, you're going to need, because that left picture has 2 trees, you're going to need 2 trees. Okay, and then seems like it takes me forever to draw here. There's 1 tree, 2 trees, and then we need a house, and then we're going to need 2 clouds because the picture on the right has 2 clouds in it, and then we need a sun. Okay. That thing I've just drawn there, that is kind of visually what the least common denominator is. It's got all the bits and pieces from both pictures. Okay, when you're kind of evening them out, when you're multiplying, then like I did in that original example, what you're doing is kind of building that LCD. Okay, so on the right you'd have to multiply in a tree. On the left you'd have to multiply in another cloud and a sun. Okay, and once you've done that, you got the LCD. And you notice, that picture that you created by multiplying in a red tree and all that jazz. That is the LCD. Okay, so that's the visual idea for you visual learners out there. Okay, let's move on to the math sort of version. Okay, and the picture now is basically the denominator. So in the beginning, in the homework problems, they're going to give you fractions like 8 over 15x squared and 5 all over 6x to the 5th. Okay, we're going to be factoring the denominators. So those are the pictures. The denominator is the picture that we're kind of trying to make common to both fractions. So 15 is 5 times 3 times x times x. 6x to the fifth is 3 times 2 times x times x times x times x times x. Okay. And I want these two pictures to match. I want the one on the left, the denominator on the left, to be the same as the denominator on the right. It's just like these two pictures. So I'm going to kind of multiply in these red, like above, I multiplied in the red tree. Here I'm going to multiply in, instead of little pictures, numbers and variables. So the guy on the left is missing a 2, right? It needs a 2 because the guy on the right has a 2, and it also needs a couple more x's. So I'm going to multiply in some more x's. The guy on the right then is missing, well, it's only missing a 5, right? So I need to multiply in a 5. Okay? And now I have built the LCD. Okay? And each of those that I just boxed in blue are exactly the same. They're just in kind of different orders. So if you multiply them out, that will be the official LCD that you put in your answer. Okay? So it would end up being 30x to the fifth. Okay. And that's the idea. Okay, so let's do some more of these. 2 all over x minus 5, and 3 all over x plus 7. Okay. Okay, in this case, the denominators are pretty much factored. There's nothing to kind of take apart. There's just one thing in each picture. So for example, for your visual learners again, maybe the first picture, the x minus 5 is just a house. And the second picture, the x plus 7, maybe that's just a tree, right? So the first picture is missing the tree, so I'm going to need to multiply in a tree. The second picture is missing a house, and I butchered what a house looks like. I think I tried to draw a tree. I meant to draw a house. Okay, so getting back to the math version then, x minus 5, I need to multiply in an x plus 7. And then for the x plus 7, I need to multiply in the x minus 5. Okay. And then my LCD is just x minus 5 times x plus 7. It doesn't matter what order you write it in. You could write x plus 5 times, or x plus 7 times x minus 5. It doesn't matter. Okay. Next, 14 all over y squared minus 49. And then the other fraction, 12 all over y times y minus 7. Okay. First denominator is not factored, so I need to factor that guy. So I got y minus 7 times y plus 7. Second denominator is already factored for me. Now I'm comparing and contrasting. The first denominator is missing a y, so I'll multiply in a y. The second denominator is missing a factor of y plus 7. So I'll multiply that in. And then finally, you could see your LCD is y times y minus 7 times y plus 7. And that's it. Next. There's 16. So I have 7 over x squared minus 5x minus 6. I'm going to have to factor that. And x all over x squared minus 4x minus 5. I'll have to factor that. So x squared minus 5x minus 6 is x minus x plus 6 and 1. And then for the other guy, x minus 5, x plus 1. Okay, so the first fraction, or the first denominator is missing an x minus 5, factor of x minus 5. So I'll multiply that in there. The second denominator is missing a factor then of x minus 6. Multiply that in there. Okay, so the LCD, x minus 6, x plus 1, x minus 5. Okay. So at this point, we want to put it all together and actually add and subtract some rational expressions with unlike denominators. So with diff, I guess that means different denominators. Okay. And we pretty much are only one kind of step away and I'll scroll up to number 16 and kind of show you how it would work. So imagine I'm adding those two fractions in problem 16. If you were to do that, you need to multiply an x minus 5 in the denominator, but if you do it in the denominator, you have to also do it in the numerator. And then for the next fraction, you have an x, but you'll also have times then the x minus 6 because you multiplied it in the denominator. Okay, so you're forming these LCDs, and you're kind of multiplying top and bottom by the missing parts of the picture, and we'll show how to do that now. And I think I title this section something funny. What did I say? So forming the LCD and combine. Yeah, so get the LCD and then combine the fractions over the common denominator. Okay, great. So let's look at number 20. 5 all over 6x plus 7 all over 8x. Okay, so the first thing we want to do is factor those denominators. Okay, so that's kind of the first thing I did above. I'm going to factor the denominator in the denominator. So 6 is 3 times 2 and then times x. And then plus 7 all over 8 is 2 times 2 times 2. And it's not always necessary to completely factor those numbers, but in the beginning I decided to go ahead and do it. Okay, so the first fraction in the denominator is missing. Looks like 2 factors of 2. Okay, so I need to go 2 times 2 in top and bottom. And eventually I will do that. So 2 times 2 in the bottom, and then, well, 2 times 2 is the same as 4, but for some reason I think I decided to write just 2 times 2 just to keep things kind of the same. And the second fraction is missing a factor of 3. Okay, so I need to multiply top and bottom by 3. Okay. Okay. Then I'm going to multiply it out. So 5 times 2 times 2 is 20. All over 2 times 2 times 2 is 8, times 3 is 24, times x, so 24x. 7 times 3 is 21 over 24x. And then finally add the numerators over the common denominator. So 20 plus 21 is 41 all over 24x, and that's it. You try to simplify if you can. In this case, that's not possible. I'm sitting on a medicine ball, so if you're wondering what is that weird sound in the background. Anyways, here's kind of one of those trivial examples. We're going to rewrite 3 as 3 over 1 and then plus 1 over x. So to make the denominators the same, on the first fraction I'm going to multiply top and bottom by x. Okay, that's what I do. Technically you can multiply top and bottom of the other one by 1, but it's a bit silly. Okay, so I don't really even bother with that. Anyways, I'll go ahead and rewrite it. And we have 3x over x and then plus 1 over x. And then finally combine the numerators over the common denominator. Okay, that's it. Next. No common factors in that one. You can't simplify it. Okay, next. Next. Number 30. Okay, you got 3 over x plus 4 over x minus 6. Okay, they're already factored. The first denominator needs a factor of x minus 6. Okay, so I'm going to multiply top and bottom by x minus 6. The second fraction needs to be multiplied in top and bottom by x. Okay, and then we'll have our LCD. Okay, so I'll have 3 times x minus 6. Those are common denominator. You could just borrow that and put that in the, x times x minus 6 is the same as x minus 6 times x. Usually put the x first though. So I'll write x times x minus 6. Okay, in the numerator then I have the 3 times x minus 6 plus the 4x. Then I distribute the 3. Oops. My screen went blank there for a second. Distribute the 3. 3x minus 18 plus 4. Combine like terms. 4 plus 3 is 7 minus 18 all over. And then there's nothing left to do. Okay. There's no common factor. You can't factor the 7x minus 18. You're kind of done. Okay. Yeah. Let's move on to problem 34. Okay, we have 3 all over y plus 1 plus 2 all over 3y. And that's it. Okay, so the first fraction needs a factor of 3y in the denominator. So top and bottom by 3y. The second fraction needs a factor of y plus 1. So top and bottom by y plus 1. Then that's pretty much it. You just combine the numerators over the common denominator. So 3y, y plus 1. 3 times 3y is 9y. So 9y. And then plus the 2 times the y plus 1. I need to distribute. So I get 9y plus 2y plus 2 all over the 3y times y plus 1. And I don't bother distributing the 3y in there, because if you can simplify later, you'll kind of have to go in reverse and then refactor, and it's just, so I just leave it alone. Okay, 9 plus 2 is 11 plus 2, and then 3y times y plus 1. Okay, that's all you could do. Yep. Okay, next. 38. Okay, so we have 8 over x plus 6 minus 2 all over x minus 6. So the first fraction needs a factor in the denominator of x minus 6. It's missing the x minus 6, so I multiply top and bottom by x minus 6. Second fraction is missing a factor of x plus 6. So top and bottom by x plus 6. And then I'm going to subtract the numerators over the common denominator. So I have 8 times x minus 6 minus 2 times x plus 6 over my common denominator. I can distribute. So what do we get? 8x minus 48 for the first distribution. It's 48 minus 2x minus 12 all over x plus 6 times x minus 6. And you know, when you're watching these videos, it's not a bad idea to just pause the video once you get good at it and see if you can do the problem on your own, and then you know, kind of fast forward to the answer and see if you got it right. If you got it right, you don't have to watch the whole thing. You could just kind of go on to the next problem. Okay. Okay. We can't factor that. You can factor out a 6, but it'd be x minus 10 left over, and that wouldn't cancel with anything. Okay, 42. 42 is a video quiz. Video quiz, video quiz, video quiz. So you have an 8y over y squared. Video quiz. This is the video quiz question. So I have 8y over y squared minus 16, and then minus 5 all over y plus 4. The first denominator is difference of squares, so 8y over y minus 4, y plus 4. The second guy's already factored, so I can just leave that alone and write it as is. Then I can multiply. I need the second fraction is missing a factor of y minus 4. Okay, so I'm going to multiply top and bottom of the second fraction by y minus 4. Okay, then I can subtract the numerators over the common denominator. So 8y minus 5 times y minus 4 over y plus 4, y minus 4. Okay, distribute. So I get 8y minus 5y plus 20 all over y plus 4y minus 4. 8y minus 5y is 3y's, then plus 20 all over y plus 4y minus 4. That numerator, you can't factor it. It is what it is. So there's not going to be any cancellations, and we're stuck. Okay. So that's the video quiz, video quiz, video quiz. Okay. Okay. Let's move on. Number 50. Cord always sticks to my table. Sorry about that. Sorry about that loud, unexpected noise. Anyways, number 50. We have 3x plus 7 all over x squared minus 5x plus 6 minus 3 all over x minus 3. Okay, so I need the factor of the first denominator. It looks like x minus, and it'll be 3 and 2. Minus 3 over x minus 3. So the second denominator is missing a factor of x minus 2. Okay, so multiply top and bottom by x minus 2. Okay. And then I could subtract the numerators over the common denominator. So 3x plus 7 minus 3 times the x minus 2 over x minus 3, x minus 2. And then that'll equal 3x plus 7 minus 3x plus 6 over x minus 3 times x minus 2. Okay. And the 3x's cancel. You get 13 over x minus 3, x minus 2, and that would be it. Okay. Okay. I think we want to look at 66 next, maybe. Yeah, okay. So this is one of those trivial ones. You have 7 plus 1 over x minus 5. So we're going to rewrite 7 as 7 over 1. And then get the common denominator and add them together. So the first denominator is missing a factor of x minus 5, of course. Multiply top and bottom by x minus 5. So you have 7 times x minus 5 plus 1 over x minus 5. Distribute, and you get the 7x minus 35 plus 1 over x minus 5, which of course is 7x minus 34 all over x minus 5. Okay, I think we got just about 2 more problems left, and then we'll go to Mymathlab. So I want to do number 72 next, I believe. As soon as I get around to it here, where is 72? Number 72. Yay. Okay, x all over x squared minus 10x plus 25. Minus x minus 4 over 2x minus 10. Okay, so I got a factor first. I have x over, that's a perfect square trinomial, so x minus, 5 and 5. Minus x minus 4, the denominator, you could factor a GCF of 2 out. 2 times x minus 5. Okay, so the first denominator is missing a factor of 2. The second denominator is missing another factor of x minus 5. Okay, let me put that in red. There we go. Top and bottom by x minus 5. Okay, now I can subtract the numerators over the common denominator. And there's 2 ways you could do this. You could FOIL first, or you can FOIL after you combine the numerators. In the video, I think I turned around and went ahead and kept the 2 fractions separate and FOILed, and then I combined the 2 numerators. But either way, it should work as long as you're careful to distribute the negative correctly. Okay, so anyways, FOILing, you get x squared minus 9x plus 20 over the common denominator. And what do we get? 2x, and then minus the second numerator. Okay. Then I got to distribute the negative. So 2x minus x squared plus 9x minus 20 all over 2 times x minus 5, x plus 5. And combine like terms. So 9 plus 2 is 11x. You notice I avoid putting negative x squared first because it's confusing. It looks like maybe the negative it should be in front of the fraction or something, so they avoid it. They want a positive leading term in the numerator usually, and if you can't get it, they'll actually kind of factor it out and put it in front of the fraction altogether. Anyways, we can't factor that numerator, so we're just going to go on. Okay, this last one has one of those opposite factors in it. You may remember the kind of trick to dealing with it was to change the sign in between the fractions and then just rewrite the denominator of the second term. Anyways, let's go ahead and right now I'm factoring. The difference of squares is y plus 1, y minus 1, and they can factor a GCF of y out of the second denominator. Okay, so in the second fraction, you see that 1 minus y. That's basically y minus 1, but you're missing a factor of negative 1. So what the fix is kind of, you could rewrite that plus in between as a minus, and then just rewrite 1 minus y as y minus 1. So that's one way to do it, and that's kind of the way I taught you before. Or you can do probably what the book is doing and multiply top and bottom by negative 1. Okay, so that will fix it if you just do that. So let me get my pen. Multiply top and bottom by negative 1. Okay. I'm also missing a factor of y plus 1, so I need to multiply that in eventually. And then the first fraction is missing a factor of y, so I need to multiply that in. Okay, so the first fraction is y squared all over the common denominator. The second fraction, and first off, I want to just talk a second about that 1 minus y times negative 1 and kind of zoom in on that here in yellow. If you distribute that negative 1, what happens? So if you multiply those two together, what do you get? So 1 minus y times negative 1. Distribute, I get negative 1 plus y. And then the commutative property of addition, I could rewrite that as y minus 1. Okay, so I could rewrite that second factor in the denominator as y minus 1 by kind of combining those two factors, negative 1 times 1 minus y. So what do I have? 5y times negative 1, and the numerator is negative 5y, and then I have the y plus 1. And in the denominator, I'll have y times now the y minus 1 times the y plus 1. Okay. Once you've done that, you can go and officially combine the numerators over the common denominator. So you get y squared. I don't know what's taking me so long. Y squared minus 5y times y plus 1. Or if you'd rather, you could write y squared plus negative 5y times y plus 1. It don't really matter. There's the common denominator. Right, so you can write, instead of y squared minus 5y, you could write y plus negative 5y. They're the same. And then you're distributing, so you get y squared minus 5y squared minus 5y all over y times y minus 1 times y plus 1. Okay. See if you can simplify a bit. So if y squared minus 5y squared is minus 4y squared minus 5y all over y times y minus 1 times y plus 1. Okay, and that'd be it. You can factor out a y if you want to, or a negative y if you want. Do 4y squared plus, or sorry, 4y plus 5, and then you can cancel that out with the y in the denominator. So goodbye. And then you could pull that negative out in front of the fraction, but what I did was just redistribute the negative. Okay. and then you get this is your answer. Okay, so that's the big and the small of it. Hopefully that makes some sense as to what you're doing. It's just a lot of practice. That's what it comes down to, having to do a lot of exercises. Okay, so now I'm going to go to Mymathlab. And just a warning, these Mymathlab problems are very long. So you may, if you get stuck on any of the problems in Mymathlab from 33 to 39, just go back to this video and zoom or fast forward to those problems. Okay, so I don't necessarily think that you should watch this next part of the video, but what I'm saying is when you do your homework and you get stuck on the hard problems, then you could use this video to kind of dive back in and see kind of how I completed the questions. Okay, but anyways, I'll go through these problems if anybody wants to, so you can, for reference, or you could keep watching, and I don't have a problem with that. But okay, so here I am. You can do this process of finding a common denominator with more than just two fractions. And here, first I factored the first denominator, and the second denominator is missing a factor of x minus 6 in top and bottom. And the third fraction is missing a factor of x plus 6. Okay. Okay, I think next I went and FOILed the numerator of the second denominator before combining the fractions. So I FOILed. So you get x squared plus x minus 42. Okay, the third numerator foiling, x squared minus x plus 42. Okay. Then we want to add and subtract those numerators. So I want to be careful with the negative on the second numerator. I have to distribute that to the entire trinomial. Okay. So I get x plus 5 minus x squared minus x plus 42, and then the rest of it over the common denominator. Combine the like terms now. X squared minus x, negative x squared plus x squared is 0. And then we have an x minus x is 0, and then another minus x. So minus x. And then 5 plus negative, the 42 is canceled, and then plus 5. And that would be my answer. Okay. Next, this one is kind of brutal as well. Just copying it down first. Factor the denominators. That first denominator is a difference of squares. Second denominator, x minus x minus, and we're looking at 5 and 6. Third denominator, x plus x minus, or x minus x plus, and of course we're looking at 6 and 5. The bigger number has to be negative. And then we're completing the pictures in the denominators. So the first one's missing an x minus 6, the second one's missing an x plus 5, and the third one will be missing an x minus 5. Okay. And combine the numerators over the common denominator. And I'll hold off on distributing until the next step. Okay, distributing. Okay, combine the like terms. So it'd be 9x minus 3x, 6x, 30, negative 10, 5, so plus 5. And it doesn't look like there's going to be any cancellation on this one. So it is what it is. Okay, next. Okay, this one has one of those opposite denominators, so I could already see on the second fraction you're going to have to multiply top and bottom by a -1 to make things work. Okay, so here I am just copying stuff down. Factor that denominator, y minus 2, y minus 7, y plus 2. The second one just is what it is, and the third one is what it is. So for the second one, I need to multiply top and bottom by a -1 to make the 7 minus y into y minus 7. Okay, so I'll do that. It's also then missing a y plus 2, so I need to multiply top and bottom by y plus 2. And then the third fraction is missing the y minus 7. So top and bottom by y minus 7. Okay, so I need to combine the numerators over the common denominator eventually. Apparently, I'm going to wait 1 second to do that. So y times -1 is negative y times y plus 2. I'll probably FOIL out the next guy. Oh, and I'm showing you, -1 times 7 minus y will turn it into y minus 7, and then times y plus 2. Plus, FOIL out that numerator, so y squared minus 7y minus 1 is minus 8y plus 7 over the LCD. Okay, now I'm going to probably put those numerators together. I'll wait to distribute this -y here on the second term, or actually that would be the third term there. Okay, I'll distribute and then start combining like terms. And the numerator, y squared minus y squared, those will cancel. 14 minus 2 is 12, minus 8 is 4y. And then 1 plus 7 is 8, so plus 8 all over y, the LCD. And then we could factor this one in the numerator. I could factor out a 4. And this one simplifies. So like every one we looked at so far didn't really simplify, but this one will. You can remove a factor of y plus 2, and you're just left with 4 over y minus 7. Next. Okay, more craziness. Now we get some multiple variables, multivariable problems. Okay. Factor the denominators. So this one, x plus 4y, x plus y. And the second guy, looking at x minus 4y, x plus y, or x plus y, x minus 4y. And the third one is difference of squares, x minus 4y, x plus 4y. Okay. Then you need common denominators. The first one, x minus 4y in top and bottom. Second one, I need an x plus 4y. And the third one, you need the x plus y. Okay. Combine the numerators over the common denominator. I'll wait to the last step to distribute. Okay, distribute. A lot of writing. Combine like terms in the numerator. And you should have your answer. You could pull the negative out in front of the fraction. I think that's the way they wrote it, or the way they have it in your answer. But the answer I wrote is also correct. Okay, some applications. So first, finding perimeter of a rectangle. Remember, perimeter is 2 times length plus 2 times width. So we'll need to take the expressions for length and width and multiply them by 2. So first 2 times, you see on the box on the side, x over x plus 4, plus 2 times x over x plus 3. Okay, I'm going to multiply those out first. So 2 is the same as 2 over 1, multiply straight across. 2 times x, 1 times x plus 4 is x plus 4, plus 2 times x over 1 times x plus 3 is x plus 3. I need common denominators. So the first one needs a factor of x plus 3. Second one needs a factor of x plus 4. And then I'm going to distribute those numerators. Oh, well, combine the numerators first and then distribute, sorry. Over the common denominator. Distribute. So I get 2x squared plus 6x plus 4x squared plus 8x all over x plus 4 times x plus 3. Combine like terms, so 4x squared plus 14x all over the common denominator. And you could factor the numerator, but it's not going to do you any good. You'd end up like 2x plus 7 times x, and there's not going to be any common factors, so it's kind of what you're stuck with. Okay, next. Okay, so we got some different variables. We get the letter h involved. Copying it down, and I copy it down wrong. When I do this, I write x plus h instead of 2x plus h, and then I have to go back and fix it. So that's a bit of an annoyance. I apologize. But anyways, please excuse my dear Aunt Sally. You have to do parentheses, stuff inside the parentheses first. So find your common denominator. The first fraction, we need a factor of x. So top and bottom by x. The second fraction, I need a factor of x plus h. Top and bottom by x plus h. Then I can combine the numerators over the common denominator. X plus h times x divided by h. I'm going to distribute. Negative 6x minus 6h over x plus times x plus h divided by h. Combine like terms. So 12x minus 6x is 6x minus 6h. And here's where I kind of realize I made a mistake, because I'm not getting any cool cancellations, which I knew I should get. You could rewrite division of h as times 1 over h. And then here I'm really starting to realize that I screwed up. Yeah, and I'm going to go look back at the answer and wonder what I did wrong here any second now. Yeah, so I'm just kind of looking up what did I do wrong, and I realize I copied the the x plus h in the denominator should be 2x plus h. Okay, but that's no big deal. I just go through and put a 2 in where I missed it. Put the 2 in there, Dave. There it is. And then I forgot to put the 2 in the denominator as well. But the numerator, the 12x minus 12x will cancel each other. You're just left with a negative 6h. And then you should get a cancellation of that h when you multiply it all out. So you'd have x times, it should be 2x plus h times h, and then the h's cancel, and you're left with negative 6 over x times 2x plus h. And now I'm realizing I forgot to put the 2 in the denominator as well. There it is. Sorry about that. And then the last one, one of these weird ones, I mentioned I won't be putting ones like this on the test. The way I solve it is just to literally think of that second fraction as like an unknown fraction and solve for it. Okay. So it looks a bit weird the way I do it. And I'm sure there's other ways to do it, but this is just what I thought up. Makes sense to me. Right, so what I'm going to do is move that blank over blank, the box over box, to the other side. I just add it to both sides. That way it doesn't have that negative in front of it. Kind of looks like I added in a box over a triangle. I didn't mean to do that. 5 over x minus 3 equals 4x plus 13 over x minus 3 times x plus 2. Plus the box over box. And then I move the 4x plus 13 over x minus 3 times x plus 2 to the left side by subtracting it. I don't show it, but that's what I did. So 5 over x minus 3 minus 4x plus 13 all over x minus 3 times x plus 2. And that equals box over box. Then I just simplify the left-hand side, and that should be the answer. Okay. So I need a common denominator. This guy's missing an x plus 2 in top and bottom. So 5x plus 2 minus the other numerator. Don't forget to distribute. And that should equal our unknown fraction. Distribute 5x plus 10 minus 4x minus 13 all over x minus 3, x plus 2. Blank over blank. Simplify. 5x minus 4x is 1x. 10 minus 13 is minus 3. So you get a nice little cancellation at the end. And that should give us the answer. So the x minus 3's cancel. And then you get 1 over x plus 2 as your final answer. Okay, well, thank you for watching, and I hope this helps a little. And I know these problems are long, but it's going to make you good at doing algebra, okay, which is extremely important. Okay, so thank you for watching, and we'll see you next time. And this is me just looking for the video quiz, making sure I gave you the video quiz, which I did.